Hey, thanks for checking out my video. Today we're going to talk about circuits, particularly the loop and junction rules. So in this example that I'm giving you, I'm going to be referring to this question here, something similar. Not all circuits are exactly the same, but you can get your information, i.e. I1, I2, and I3, using a similar method. So I'm going to be going back and forth from this to the whiteboard and vice versa. So the junction rule in general is just a way that we can sort of analyze the junction or the meeting point of, or at least a meeting point of a circuit. So it could be A, it could be B, that doesn't really matter, but it is a point similar to what I've drawn here on the right. And essentially what we're measuring is the currents going in versus the currents going out. And algebraically, this will line up to be that the currents, or I, going in will equal I going out. So if, for example, we're saying 5 is going in, 5 is going to go out. That's the main point. That's the end of the story. Now, you probably saw that this drawing that we had on the quiz did not give you any arrows. So I drew my own. Oftentimes they will give you arrows. I'm not sure why this one didn't have any, but essentially the arrows that I drew were like this. Bear with me since I'm drawing. So that's I1, remember that's the current. That's 2. Which way was that? I want to draw that this way. Yep. So I1, I2, and I3. Of course, this would be a lot easier to show on paper. But essentially, okay, so this is what's going on at that junction, right? And what we can conclude is that I1 and I3 actually are going in and I2 is going out. That means that I2 is the sum of I1 and I3. This would be the same thing if you rearrange the arrows. It's going to be the same general formula, you know, as long as you have what equals in and what equals out, you know, you have them on different sides, you know, you're on the right track. So that's what I did here. That's the first part of the solving circuit process. So what I would do is I would actually write down your particular junction rule, because remember, they're not all going to be the same. It really depends on what you were given. Now, there is a little bit of algebra involved in this. My favorite way of solving things like this is substitution. Actually, scratch that. My favorite way to solve this is elimination. And if you recall from algebra, elimination is essentially when you have sort of like systems of equations and you want to sort of combine them by getting rid of one of the variables. So maybe you have an x and a y in the equation number 1, and then you have an x and a y in the equation 2, and you want to essentially get, you know, the equal and opposite forms of the equations so that they can sort of smush down and make one. So that being said, then just believe me when I'm saying this, you're going to need to have I1 and I3 be substituted into your formula or into your equation at some particular point during your solving process. So what that means is you want to have 2 equations that have I1 and I3 in them. Think about this. If you have an equation that is x and y, can you solve a system of equations if it's y and z and x and y? One being y and z and the other one being x and y? No, you can't, because, you know, one of those variables isn't really going to be able to cross out. So that being said, you have to be able to choose your loop in terms of what you know 100% is going to be able to cancel out. So if we know that we want to have I1 and I3, what you're going to do is you're going to circle the loop that has I1 and I3 in it. And I'll use my orange here. So this loop here, this big one, has I1 and I3 in it. So when you're writing your loop equation, you'll have R1, R2, so on and so forth, and it'll have an I attached to it. And then other variables will have an I3 attached to it. So we can cross that off. So how can we ensure that the other equation is going to be able to cancel out? Well, we have to consider what can I circle that's going to make substitution easier for me. That means that you have to have something that's going to be able to have I1 and I3 at some point. So you can circle I1 and I2. Let me do different color. That's a nice color. If you circle I1 and I2 as your second loop, that means at some point with substitution, you're going to sub in 1 and 3 for your 2 value, and eventually you'll get a very similar equation to your first one, which was I3 and I1. So in the end, you'll get two equations that both have the same variables, and that's what you want in the end. So that is the first part of that. First, you want to do your junction rule, then you want to look at your loops, make sure you're able to do elimination with it. If you're not a fan of elimination, choose whatever loop you want, but I find it to be the safest option. So you want to do that. And so now your next question would probably be, how do you write your loop rule? And this is going to depend upon what you actually choose, right? The loop rule is not going to be a set rule for every single circuit. It's going to vary depending upon what loop you choose and what the contents of each loop are. If you have different resistors, if you have different batteries, it's going to vary from what you're doing here today, but we're using this as a general example. So let's head back to this question, right? And hopefully you can see my cursor here. Let's say this is a point A. And you can take a picture of what was on the whiteboard, and then you can compare it to this now. So if that is sort of our rendezvous point, and make sure you're keeping track of what you're actually writing. You want to make sure you've written all your values correctly. Make sure that you are labeling your not kind of exponents, but whatever sort of coefficients and so on and so forth. Make sure you write every single little thing down. So the first thing you're going to do is you want to get the big loop, right? So you want to make sure that you get this, this, and this in your big loop. If you remember the direction that I gave you, the current is going really from this way to that way. That's the direction that I1 is going. It's going clockwise. So it's going from this way, sort of like that. And if we're traveling in the direction opposite to that, that means that this resistor, this R1 value, is going to be positive. If it was the opposite direction, and by that I mean if the current was going in the same direction that we're traveling, it's going to be negative. So opposite directions means that the resistor is going to be positive for that value. Moving on to this sort of battery, you're going to sort of have like a jump from here to here, and this value, or this side, is going to be positive. So if you're going from the positive side to the negative side, you're going to keep your E1 value as negative. So right now, if I'm looking at my notes for the loop 1 and 3, you should have written down plus I1, R1 minus E1. So you want to include the current, right? That's I1 going in this direction. That's attached to the resistor. That's R1. And then you want to subtract E1 because we're going from the positive to the negative side. So keep that in mind. The value for E has nothing to do with the direction of the current, whereas it just has something to do with, really, if you dial it down, which are you going from the long side to the short side or the short side to the long side? So that's that. And right now, you don't have to put in any variables. I just like to sort of frame out what my loop rule is first, and then you can plug in your data later, which is written here. Sometimes you'll have the resistors and the batteries as values of their own on the picture, but sometimes it's not. So you want to continue doing that. Now we're hopping over this way. And if you remember, the current here is I3. I3 is going in this direction. So it is going counterclockwise. So that means that when you're going past R3, it's going to be negative. So you would put negative I3, R3. And again, if it was going in the opposite direction, if I3 was going this way, if we were traveling that way, it'd be a different story, it'd be positive, but since they're going in the same direction, it's going to be negative. So that's how you get your loop rule for 1 and 3. And obviously, you know, things can be a little bit challenging with Zoom, as I've said multiple times on my channel, but it could be helpful, I guess, if I write sort of my loop rules if you're interested in seeing them. You know, I guess if you wanted to just skip this is probably going to be a long video. I'm here to tell you that right now. So let me go ahead and write, you know, some information here, and make sure you label everything. So loop 1, 3 is I1, R1 minus E minus I3, R3. Now it's just one of those things you sort of need to like circle and save. And now we can move on to going back the other loop. So we did the big one, now you want to do the small one. And essentially, by doing this, you're going to get some similar data, right? This is still going to be positive, that's still going to be negative, but this time we're going to loop around this way. And the current we come in contact with is current number 2, which remember is going out of the junction. So that means that it's going this way, not up. So it's going down from point A, if that makes sense. So if we're traveling around this way, we're going to hop from the positive side to the negative side again. So you're going to have a negative E2 value. Then you're going to do, you're going to go through R2, but in this particular case, R2 is going to be positive, and because they're going in different directions. So you end up having your second loop, which we can go back to the board here. Your second loop is going to be, shoot screen. Loop 1, 2 is going to be similar to I1 in the first aspect. Then we're going to have, actually put a 1 there, I forgot. Let's see, E1 minus E2 plus I2 R2. That's the second one. So we've already made some great strides here. We have our junction rule, right? We have our first loop rule, and then we have our second loop rule. Also, the next thing you really want to do, at least the thing that I do, is I fill in the information that is necessary. So, you know, if we don't know what I is, we don't know what I1 is, we don't know what I2 is, we don't know what I3 is. That's what we're doing this whole process. What we do know are the R values, and we know the battery values, which are the E values. So what you want to do is sort of substitute. So R1, for example, the value of R1 is 87.9. So what that means is that you want to go back and plug in 87.9 in front of your I1. You're going to plug that in here. Then you want to put in your battery value. Then you want to put in your R3 value. You want to do the same for this. And what you got to make sure that you're doing is if you have any like terms, so in algebra, like terms means you have, you know, a couple X's, you have a couple Y's, you have, you know, two sets of X, Y. You know, you can add similar things that have the same coefficients. So that being said, there's not a whole lot of that here, but you can definitely combine battery values here because, they're both in voltages. You can't combine an E value with, resistance or current, especially not, you don't want to do anything like that at this point. But now is mostly about substitution. And when you're done with that, what you want to do is you want to sort of come up with two equations that are the result of you substituting in your given values into these equations and combining like terms. So you're going to get, if you're doing this right, I will write this is what you should get for your, I wish this was a lot. There's an eraser option here. What does this do? Oh, that's a lot easier. Why don't you tell me? All right. Yes. So what you should be getting, and I'll call what? Yes. Can I draw? Why am I not drawing? Oh, that. Wow, this must be difficult with me. Oh, you know what? Yeah, that's Zoom for you. All right. So you should have 1 as your junction rule, which is I2 equals I1 plus, bro. Plus I3. Then 2 is going to be your loop rule. So let's just write 2 there. Your loop rule for your first loop, and 3 is going to be, let me just do L1. 3 is going to be L2. And then you want to have a 2B, which, like I said, is essentially the culmination of your substitution of your given values. You're not doing anything crazy here. Your substitution of your given values with combining like terms. And that's going to give you 87.9. I like to include this little resistance symbol. I1 minus 40 minus 70 and you want to make sure you write equals 0 at the end. Because, like I said in the beginning, you're going to be doing elimination, and you may remember from algebra class that you cannot just multiply through by something or divide through by something and expect it to all go away unless you have an equal sign. It's sort of like, I guess, I don't know, you don't need to have so many analogies, but, you can't just keep shoving stuff into an open trash can and expect it to be taken out, right? You have to take it out yourself to the trash for it to be picked up by the garbage collector, okay? So that being said, you need to have an equal sign because you're going to be dividing through and multiplying through to get your answer. And then you're going to have 3b, which is using your second loop. And if you did calculations correctly, you're going to get 87.9 I1. So hard. That's I1. I1. What are you? Yeah, minus. What did I do? Hold on, no. Let me erase real quick. I'm looking at my notebook. You should get this one. Okay, so save that one. Yes, you should get 110.3. I1 plus 22.4 I3 minus 39 voltage equals 0. Okay, so you should have your two equations here. I believe that is correct. Yes. So that's what you're going to have if you did your calculations correctly. And excuse me for not, talking as fast as I possibly can, but I'm making sure that I wrote everything correctly, transferred from my book. So yes, that's correct. So, there's no reason to really go over elimination here. I mean, that's probably a YouTube video of its own, but essentially what you want to do is you want to see, all right, well, I have my I1 and my I1, I have my I3 and my I3. Like I said in the beginning, you want to make sure that you have something that can cancel out, right? If you had an I2 up here, if that was an I2, it's just not going to work out. It's not going to sort of fold on itself to give you your end result. So the question is, how do you get a 87.9 to a 110.3, or a 22.4 to a 40.0, to a negative 40.0? Or essentially, actually, how do you get it to be able to sort of add together? How do you get this number to be able to cancel that out? So really, that's going to be positive. And what I ended up doing, actually, is multiplying this 3b, I believe, by positive 3.125. So what that did was it made this 22.4 equivalent to the 70. Why did I say 42? Okay, yeah. You guys know what I'm talking about. Let me actually highlight this. 50. Yes. I3 and I3. Yes. Okay, yeah. So essentially what I did was I multiplied by 3.125, and that was able to get my 22.4 to the 70, which was able to cross out the two 70s. And then I was able to combine all the like terms from both the equations, which gave me 332.58 I1 minus 1265 equals 0. And eventually you get I1 equals 2.9035 amps. Now, you're not always going to get the same sort of I1 first or I2 first. It really just is the result of what your junction rule was to begin with, or, what loop you chose. So it's really going to vary. But in the end, you're going to get one variable, hopefully, if you did it right. And you might get I1 first, you might get I2 first, you might get I3. And then once you get the value of I1, you can plug that into one of your equations to begin with. So you might want to plug it into your 2b, and that will give you I3. That equals positive 3.0745. Now we can use the junction rule, which will give us I2, because we know that I2 is the equivalence of I1 plus I3, and that will give you 5.97808. If you're using a homework or a test sort of website like mine, you're going to have to be specific. So oftentimes, there's no need to round in any type of crazy shape or form. But that's essentially what you have to do. I can do another video on how to do elimination in full, but this YouTube video has been long enough. So hopefully I was able to give you the information that you needed. and I hope you know how to solve circuits now. So it's my bedtime. I'm gonna go, and I hope it helped. So I'll see you in the next video.